So.
Since college, so it's really nice to see that. Hopefully you guys can burn your hands on them, because I definitely have before, so be careful. Also I wrote some notes, so if I pause and look, maybe jog my memory. And again, if you guys have any questions, feel free to ask me as we go. I'm totally open to answering anything. Currently I am a co-founder at a company called II Wisdom. It sounds like II like an iPhone, but in fact II stands for Institutional Investor, which previous to me founding this company, I had no idea what that was. So what I kind of want to go through with you guys is my background and kind of how I landed where I am now, which sounds like it has nothing to do with electrical engineering, which is my original background, but as you'll see, it is, in fact. So I'm originally from St. Louis, Missouri. If you're not familiar with that area, it is literally in the middle of the country of the United States of America. So I wasn't fortunate enough, like you guys, to live out in beautiful California. So I made the decision to come out here for college. And when I was your guys' age, I was trying to figure out, what I wanted to do with my life and my career, because, you have to make those decisions when you're 15, 16 years old. You don't, just be fair, but I felt like I had to. And I was really good at math and science and physics, and I loved that, and so I decided, I went to a Purdue engineering camp, which wasn't as cool as what you guys are working on, but it allowed me to see what disciplines in engineering existed. I really just knew about mechanical and civil, but I learned more about electrical and chemical engineering and programming and all that stuff. And I became obsessed with the idea of signals, like AM radio and FM radio, and how things are, there's data, in our air, being transmitted to antennas and stuff. So that's kind of what piqued my interest in electrical engineering, was understanding how signals work. So I decided, I can't even remember, I'm so old, that what I decided on at 18. But I decided when I was graduating high school, I was going to go to Santa Clara University, which is like an hour south of here. I really wanted to be in Silicon Valley. I figured if I was going to be an electrical engineer, I might as well be around where modern technology was founded. And I went in knowing that I was going to be an electrical engineer, and I was just so focused on I was going to do electrical engineering. But I had the opportunity of working in civil engineering and mechanical engineering and biomedical engineering and computer engineering, because every project I worked on had all of those elements involved somehow. For example, my senior design was called, so just a little background, at Santa Clara and a lot of universities, you have to do a senior thesis or a senior design, and with that, it depends on how much time you guys spend on it, varying on the university. Mine was over a year-long project that you decided on in junior year, and mine was it was called the blood vessel recognition device. And what we did was we took these blades that originally cut through people, like in surgery. And I don't do well with blood, so I was completely out of my comfort zone. And what we were doing was we were detecting blood vessels in the body to see, if a surgeon is cutting through someone, if they cut through a blood vessel, that leads to blood everywhere, and it's just really gross. And I wouldn't want to be the person who's, bleeding out during a minor surgery. So we decided we would use a piezoelectric device on this blade. And what the piezoelectric device did was it sent out a signal when voltage was applied to the piezo. So what happens is this little piece of metal contracts and sends out a signal. So what we were doing is we were sending out the signal, but in air, the signal is one way, but we were doing it in a body. So we first started out with a petri dish, so just like a gelatin, like Jell-O, although it doesn't taste as good. And so what we were doing was sending out signals through there, and then it was coming back in, and we were receiving the signals through the piezoelectric. and then deciphering based on Doppler theory, which you guys might be familiar with, where the blood vessel is located. So not only did I work on, the electrical engineering design of that blood vessel, but also the computer programming to make sure that, we were getting the right signal and kind of breaking down the signal using computer science. And then also biomedical signals is completely different from signals that we're used to in Bluetooth or Wi-Fi or AM radio and all that. So I was learning everything about biomedical and computer science along with electrical engineering and mechanical engineering, because the piezo had to be a certain way for it to fit into the actual blade that is used to cut through the person. So again, I don't do well with blood, but we tested it on, I hate to say this, but it was an already dead animal, and I love animals. So we were in there, we were practicing and cutting, and I actually passed out during this whole process because I just couldn't handle it. The blood, it was bad, but it worked. So we were able to detect the blood vessel while we were cutting through. I don't remember that part because I had passed out, but we did get the right signals and everything. And so that was a really good chance for me to see, biomed, electrical, computer. And I figured out what my strong suit was and what wasn't. Mechanical engineering, I wasn't very good at it. Electrical, I love the equations that went with electrical engineering, and programming for me, and I'll get into this in a bit, but that instant gratification of, your code's working and something is showing and something's moving, something's working, whether it's your firmware or website design or anything like that. It's a very instant gratification as opposed to hardware design. You build it, you build the schematics, you build the layouts, and you send it out to get built, and then it comes back, and then it doesn't work. And so you have to go through that process many times until you actually have a working hardware device. And computer engineering, you can get your software in, and you can hopefully get something working a little bit quicker than hardware. So I also, aside from the project I worked on in senior design, I also interned at Palm. You guys might not know what Palm was, but have you guys heard of the Palm Pilot? Okay, so they were like the first smartphone before the smartphone was actually a thing. And what happened was Palm came in, or not Palm, iPhone came in and just killed everyone. Like everyone's, smartphones were just completely annihilated by iPhone. So when I joined the company, they had to differentiate themselves in the market. And that involved, taking their form factor of Palm Pilot, which if you guys had ever seen one, it's very clunky, it's very heavy. There was a stylus, which I know styluses are back now, but at the time, Steve Jobs was like, you can't do a stylus, which I kind of agree with. So we decided to do a touchscreen device that was a palm in your hand device. And it was going to be smarter, it was going to have a better OS. So I was able to work on the power management side where in order to differentiate ourselves a little bit, we use wireless charging to actually dock and charge the phone. Do you guys know what wireless charging is? So this blew my mind because putting, two magnets together and creating an electromagnetic field was actually charging the phone. I mean, that was just insane. Like, to me, it was magic in a form factor, and it was actually working. So I was fortunate enough to work on that, and that was very power management heavy, electrical engineering heavy. But I was in the lab 24/7, and I was either building programs to do testing, or I was soldering under a microscope. So that's why I used really thick glasses, because that's not really why, but it didn't help. But I decided, I wanted to be out and talking to people and, you know, doing more business development. So when I graduated, I decided I was gonna work for Texas Instruments. And there I was gonna do more of a business development side, working with various end equipments and customers and trying to help them with their designs. So I'd have the opportunity to see all the different products that are out there, from servers to cell phones to smartwatches and everything in between. There's a lot of crazy things that you can build with hardware, and I've seen a lot of it. So as many of you might know, Texas Instruments sells calculators, and I'm sure a large majority of you actually have one. But they also sell semiconductors. So semiconductors are, you know, the reason why all these electronics are able to work. And so it really was the root of, you know, all this technology. And you might argue, what comes first, the chicken or the egg? Is it the technology that's created, or is it the semiconductor that's created to help create the cutting edge technology? So I was really embedded in the nitty gritty of, you know, really building a system. And I enjoyed that. However, I was working with so many different clients and different products that I really couldn't get to know and build a product on my own, which I was really enjoying when I was at Palm and my experiences at Santa Clara University. So I quit. I just completely quit. I didn't have anything lined up, but I knew I didn't want to be there. I wanted to build something on my own. So I worked with a group. I was going to ask you guys if you know Arduino, but I've seen a couple Arduino boxes, so you might be familiar with that. So our